Okay, so we have explored with the penny million activity. We've explored a little bit about linear versus exponential. We want to kind of get into the nitty gritty of linear versus exponential. So what I want you to do now is I want you to do A and B together with your groups, okay? So realize that those are two very different things. A is 2x. What operation is that? 2 times x, right? So as you're plugging numbers in from your table to find your y values, you are simply multiplying by 2, okay? On B, that is not 2x. That is 2 to the x power. So as you're plugging numbers in from your table, you need to make sure you're using that exponent button on your calculator. So you will hit 2, exponent button, and then the number that you're plugging in, okay? So make sure you're careful with that. So what you need to do is on A and B both, you are going to first fill in the table of data using your function, and then you are going to plot your ordered pairs and see what the graph looks like, okay? So I'll give you guys about 5 minutes to do that for parts A and B both, okay? A and B both. Go ahead. Okay, all right, so let's look at A. If I'm filling in the table for A, I'm simply multiplying by 2. So 2 times 0 is going to give me 2. 2 times, oh no, wow, guys. I literally just did that on camera.
Good job.
I want to officially apologize to anybody listening to this video that just heard me say 2 times 0 was 2. All right. I'm just going to pretend that didn't happen. Okay. 2 times 0 is? 0. Now you guys are just messing with me. 0. Okay. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. Okay? So then graphing this line, I have 0, 2, 4, 6, 8. There we go. And it is going to be a linear function, right? It's going to be a straight line. Okay? So we've talked about that. Now let's look at B. Okay? So B, now I'm taking it to the power, to the x power. So 2 to the 0 power. You guys should know this. What's anything to the 0 power? 1, right? So anything to the 0 power is 1. 2 to the first power is 2. 2 squared would be 4. 2 to the third power, that's 2 times 2 times 2, that's 8. And then 2 to the fourth power would be 16. So you can see, just like we were talking about before, that's going up by a constant factor, not a constant rate of change, right? Linear is constant rate of change. Exponential is constant factor. So as I'm graphing this, I have 0, 1, 1, 2, 2, 4, 3, 8, and then 4, 16 is going to be up off the graph, okay? So as I extend this way, we have the J curve going up that way. As I'm coming back towards the axis, one super important thing to realize about exponential functions. Unless there is a negative in the problem, in the like coefficient, the base that you're multiplying, they are never going to go below the axis. So as I'm extending my graph back the other direction, it is going to approach but never touch or cross that x-axis. So that is one absolute important thing for you to realize there. An exponential function, unless there's a negative in the base, will never go down below or touch that x-axis. It will approach and get really, really close, and to the naked eye it might even look like it is touching that x-axis, but it never actually is. Okay? Okay, so now let's compare and contrast, okay? So what I need you to be able to do by the end of the day today and moving forward is to tell if a scenario is linear or exponential. And we need to be able to do that with multiple representations of data. So let's first just focus on the graphs. That should be pretty simple, okay? So have a quick 10-second conversation in your groups. How do you know if a graph, just looking at a graph, is linear or exponential? Ready, set, go. Okay, guys, how do you know a graph is linear? How do you know you're looking at a linear graph? It's a straight line. Good. So if I'm looking at a graph and it's a straight line, I know that it is linear. How do I know I'm looking at an exponential graph? Okay, hold on. What? Okay, it is a J curve because at some point this semester we're going to be looking at U curves as well. Okay, so we have to remember it's a J curve. Specifically, some verbiage that is generally acceptable when you're talking about an exponential function is it starts growing quicker and quicker. So it's growing really slowly in the beginning and then it just takes off. It starts growing quicker and quicker throughout the thing. Okay? We also have exponential functions where we have exponential decay. So it's shrinking really quickly and then it shrinks slower and slower and slower. So if you see one that goes the other direction, that's still exponential. Okay? All right, so comfort level on being able to tell if a graph is linear or exponential. Awesome. Okay, now let's focus on just the functions. Not the tables of data, just the functions. Just exactly what the functions look like. So have a quick 10-second conversation. And I'll give you a little bit more time. Have a quick 20-second conversation in your group. How do you know you're looking at a linear function versus an exponential function? Go ahead. Okay, linear functions. How do you know you're looking at a linear function? Yep. Yep. That's the graph. We need to talk about the function, the actual equation. Let's talk about what it doesn't have. What does a linear function not have? The exponent, right? So that's the key. When you're looking at functions and trying to determine what's linear and exponential and neither, you have to focus on the exponent, okay? And I do want to flush something out really quick, okay? So here we have no exponent. Which means it's linear, right? On B, what is the exponent? X. So specific to exponential, the X is the exponent. It could be a different variable. That's not going to change anything. What you need to make sure and look for an exponential function is that the variable is an exponent, okay? I do want to throw a third category over here, okay? So x is the exponent, that means it's exponential. So let me throw a part C over here, okay? Okay, so if you look at the function y equals x squared, okay? You look at the function y equals x squared. Is there an exponent? Yes, so it's not linear, right? Because it has an exponent. Is the exponent an x or a variable? The exponent's the variable? Oh, that's a 2. Sorry. You thought it was a z. Okay? The exponent is 2, so it is not exponential either. So this would be a case where we would say neither. Okay? Because it has an exponent, so it's not linear, but the exponent is not a variable. So that is neither. We will actually learn about what this is called later on in the semester. Okay? All right. Let's not focus a bunch on that, but I just wanted to show you that so that you're prepared. Okay, so can I get a comfort level looking at the equation or the function? How do you feel about classifying linear versus exponential? Good, 2s and 3s. Perfect. Okay. Now let's look at the tables of data. So looking at the tables of data, go ahead and have a quick 20-second conversation in your groups. How do you tell if you're looking at something that's linear or exponential from the table of data? Ready, set, go. Oh my gosh. gosh, we're almost out of time.
I know.
Okay, I didn't realize we were running so short on time. How do you know you're looking at a linear table of data? Guys, stick with me for just a minute more. How do you know you're looking at a linear table of data? Good. So a constant rate of change. So we're going +2, +2, +2. How am I going from piece to piece on the table of data here? Times 2, right? So I'm doubling. I'm going times 2, times 2, times 2. That is a constant factor. Linear is a constant rate of change. Exponential is a constant factor.